Hello, everyone. It's great to be the first one to talk, right? Even though my talk might not entertain you this morning, but at least I'm not the one preventing you from getting lunch, I guess. So, and I may have a chance to get in or leading the line for lunch. I don't know if you don't have a question for me, so I'm the one doing that. All right, so my talk today is Dairy Forage Fractionation system. We're developing that right now. And just quick background, right? We only have 8 minutes. We'll be really quick here. So as we all know, dairy forage, right? Corn silage, alfalfa haylage are very diverse, very ununiform, right? Think about those leaves, stems, grains, or what have you. In there's a mix of parts, right? You have many different shapes, size, nutrients, digestibility, very across the board. So we are really looking at a way to better make the value out of that mix of materials. Right? And there's existing systems which are either too energy intensive, too costly, or simply cannot handle those wet forage materials. Right? Think about alfalfa haylage. So we are in the process of developing and evaluating the what we call a dairy forage fractionation system, DFF, in short. So today I'll be presenting to you two things we have done so far, the survey study and also the prototype development. I'm an engineer by trade, so I'll be mainly focused on the prototype, and then we have questions. If you have questions about the survey or economic assessment, my colleague, Dr. Harvey, will be the person to ask. I just pretend I know those things right now, but let's see how it goes. So we have done a survey with farmers, basically looking to get their opinions on their willingness to pay or to adapt and their preferred capacity, energy source, and acceptable price range, etc. So that's what we try to get out of the survey. And we really had a great response from small family farms to larger operations across the state of Wisconsin. So a couple lessons from that survey study. First is we figure out that as we expected, right, larger operations, they are willing or more willing to adapt this new system technology, and small farms, they are they are more sensitive to the price, to the cost of the investment. And then the other thing we really learned from the survey was most producers would process about 1 to 5 tons of haylage per day for the operation. So that kind of supports the level of scale or the level of capacity we will develop for this new product. And then one of the very interesting message we got very often from the survey result was, well, the farmers, they really emphasize, right, the viability in the alfalfa haylage really changing a lot. And also they rely on supplements to make the system work, to make more milk. So that's really emphasized or really proof that there is a need in the industry for such a system to work more effectively for the feeding efficiency. All right, jump into the more technical part. So right now you see this is the prototype number 2, which we have developed and tested and got some data, and we're in the process of developing prototype number 3. So what do you see here on this picture? On your left, that's the separation system. It's a trauma-based screen rotating at a different angle, different speed, different parameters to testing the separation efficiency. On your right, there's a blue system. That's what we call the feeding system to make a consistent feeding delivery to the separation system. So again, this is prototype number 2. We have developed the prototype, built, and done some tests, also built a digital twin computer model to be more effective in developing this new system. And then we have gathered data, so we can use those data to further develop what we're doing right now, prototype number 3. So we're now showing on the screen there's a digital twin model, discrete element-based method-based digital twin model. So we can use this to test many different aspects of the system, right? Whether that be a design parameter or operation parameters. So some couple things about this model, right? The material, you see tumbling in the screen that has been tested for the properties And the model itself has been calibrated and validated against very rigid physical tests. So we have a full confidence this model is representing most major behavior of this system. So what this model allows us to do, well, first thing is, as an engineer, right, we have, in the process of designing a new product, we have many unknowns, right? This model really helps us to determine the design and operational parameters. Couple examples shown on screen, right? We're not sure about the hole size, about the screen, the angle of incline, or the angle the screen is sitting at, the speed of rotation, right? We have a rough range of those parameters, but we are not sure what is the best parameter or what is the best combination of those parameters. So this model really helps us to test the best combination is those numbers for our application for the crop or material condition we were testing at. And then we also run some physical tests to experimental tests to further validate the model and gather more information. Couple examples here, we investigate the effect of the mass flow rate, right? What is the capacity of the system can handle, and also the screen rotational speed on this. So for the test, we mainly focus on two things. One, showing on the right picture here, we have 4 bins underneath the separation system, so we can collect what is the weight across the material flow direction. So we can say what is the headage material distribution along the process direction. And then the other one you see on the bottom there, there's a AI-based image analysis system which we developed to basically get a better understanding of not only the distribution, but also the composition of the sample in those bins, right? We have a rough estimate of the weight of the nutritional value, but what is the actual value for animals, right, for feeding value? That will be answered by those AI techniques to further get the fine details of what is actually the potential benefit of this system. So far, some preliminary results we had so far. The UNet deep learning model was reasonably accurate, right? And then the focus here is with very limited training data sets, right? We do not have any contractor or any existing data source to use for training the model. Everything is being collected in the lab by my students, so very limited data set. With that limitation, the model is fairly accurate. I would not get into details, but I can tell you is at least satisfied what we are looking to get out of the data. And then the separation efficiency increased according as the increase of the mass flow rate. And we haven't reached to the peak yet, which is a good thing, right? That's basically allow us to further increase the flow rate, which is a higher capacity for the system. So there's potential there, right? We can keep increasing the flow rate to make it a higher capacity. And then I want to emphasize that we're still in the process of analyzing those data and then processing what we have so far. And we're actively looking for help, for collaboration with if you're students in the audience. So I'm looking for students to help. If you're interested in this project, reach out to me afterwards. If you are farmers or industry partners, I'm looking for collaborations for animal trials, for feeding trials, very down the road, right? That's the goal of this project. All right, I think that's my time. Thank you.